Good afternoon, guys. Today we will be studying Introduction to Euclid's Geometry. So, I'm gonna cover the whole chapter in this video, and please ignore this. I don't know what is this. It's coming in the. I don't have much. Like I have space, but like the table which I need, I don't have it right now. Okay, if you grow my subscribers, maybe I'm gonna get that. Okay, we have upgraded our channel. What am I speaking? I don't know. I've upgraded my channel for a nice phone stand. So this is my first video by a phone stand. Let's check this. Okay, so let's start. Introduction to Euclid's Geometry. So Euclid's Geometry. Wait, let's read this. So Introduction to Euclid's Geometry. The word geometry comes from the Greek words geo. So geography, you know that, but it's not related to it. It's fully another word. It's a Greek word of geometry. So geo means the earth, and metrian, it's meaning to measure something. And geometry appears to have originated from the need for measuring land. So it's speaking over here, geometry appears to have originated from the need for measuring land. So you must be thinking, why am I covering this chapter? So that's because like in this chapter you don't have to do any calculation or any like 180 degree or 360 something like that. We are going to cover the whole chapter in this video, and in this chapter you only have to read things. I know this comes in 9th, I think PT2. It comes in PT2, which is of depends on your school of how many marks, 50 or 40, maybe 20. Okay, so let's start. So here, the branch of mathematics was studied in various forms in every ancient civilization, be it in Egypt, Babylonia, okay, it's a place, China, India, Greece, the Incas, etc. The people of the civilization faced several practical problems which required the development of government in various ways. So now, first of all, we are gonna see. So let us remember the names: Egypt, Babylonia, China, India, Greece, and Incas. So these are some places' name. They used to exist like this. It does still existing, by the way. We all live in India. We know. I know my video never goes out of India because I depend on India's book. So, for example, whenever the river Nile, so you must be knowing Nile, it is the longest river, overflowed, it wiped out the boundaries between the adjoining fields of different landowners. After such flooding, these boundaries had to be redrawn. For this purpose, the Egyptians developed a number of geometric techniques and rules for calculating simple areas and also for doing simple constructions. The knowledge of geometry was also used by them for computing volume of granaries and for constructing canals and pyramids. They also know the correct formula to find the volume of a truncated pyramid. See figure 5.1. So you can see this figure over here. Let me wait. Okay, this. See breadth, height. Okay, so you know that a pyramid is a solid figure, the base of which is a triangle or square or some other polygon, and its side faces are triangles covering to a point at the top. So let us head to the next page and let us know it much more better. Wait, this is a part of when nobody used to know what is geometry, when people didn't used to know that. So in the Indian subcontinental, the excavations at Harappa and Mohenjo-daro, etc. Don't mind my pronunciation. I don't know how to pronounce it correctly. I'm still a student. I'm still in 9th. Like I'm not failed, but I'm still in 9th. So this is my first year in 9th. Let's go. Everyone has a first year, so let's just move ahead. Leave my story. We'll tell you some other day. Okay. Show that the Indus Valley civilization about 3000 BC made extensive use of geometry. It was a highly organized society. The cities were highly developed and were well planned. For example, the roads were parallel to each other and there was an underground drainage system. The houses had many rooms of different types. This shows that the town dwellers and skilled in mensuration. It's not menstruation, it's mensuration and practical arithmetic. The bricks used for constructions were fired, and the ratio length breadth thickness of the bricks was found to be 4:1. I think I shall not cover this. Let's just go ahead, leave this. No, let me just explain this. In India, the Sulabhastra 800 BC to 500 BCE were the manuals of geometrical constructions. Geometry of the Vedic period originated with the construction of altars or Vedas. The fireplaces for performing Vedic rites. The location of the sacred fire had to be in accordance to the clearly laid down instructions about their shapes and areas. If they were to be effective instruments, square and circular altars were used for household rituals. So household rituals are mostly done in India, you must be knowing. Many people do puja and many stuff. So while altars whose shapes were combinations of rectangles, triangles, trapeziums were required for public worship. The Sri Yantra given into the Arthur Veda consists of 9 interwoven isosceles triangles. Those triangles are arranged in such a way that they produce 43 subsidiary triangles. Through acute geometric methods were used for the construction of altars. The principles behind them were not discussed. These examples show the geometry was being developed and applied everywhere in the world, but this was happening in an unsystematic manner. What is interesting about these developments of geometry in the ancient world is that they were passed on from one generation to the next, either orally or through palm, leaf messages, or by other ways. Also, we find that in some civilizations like Babylonia, geometry remained a very practical oriented discipline, as was the case in India and Rome. Geometry developed by Egyptians mainly consisted of statements of results. There were no general rules of the procedure. In fact, Babylonian and Egyptians used geometry mostly for practical purpose and did very little to develop it as a systematic science. But in civilizations like Greece, the emphasis was on the reasoning behind why certain constructions work. The Greeks were interested in establishing the truth of the statements they discovered using deductive reasoning. See Appendix 1. Okay, till now I don't know if you're understanding or not. I would just ask once, please understand this. So I know I'm not good, I can't explain nicely, but still I'm gonna read this for you. Maybe you can get, and don't mind my reading also. I know everything is bad. Why is this shaking? Wait, yes, stop shaking. Yes, a Greek mathematician, Thales, is credited. See here, Thales' photo. First known proof. The proof was of statement what a circle is bisected. So he gave a proof of the statement what a circle is bisected. So bisected means like it's cut into 2 equal parts. Okay, like a line is going through it and it's gonna cut it with 2 equal parts. So by its diameter, one of the Thales' most famous pupils was Pythagoras. So I know everybody hates Pythagoras. So because of Pythagoras theorem, and Pythagoras was of 572 BCE. Whom you have heard about Pythagoras and his group Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. This process continued till 300 BC. At the time, Euclid, a teacher of mathematics at Alexandria in Egypt, collected all the known work and arranged it in its famous treatise. So let's just head to the next page. This chapter has many things to read, so I think this all is of no use right now. Let's just read the axioms and postulate, which are the main things of the chapter. So I think let's just leave this. Now see, you can see here first of all Euclid's definitions, axioms and postulate, and here's Euclid's photo, 325 BC, 265 BC. So from this we can see that Euclid, he lived for many years. For example, for 265 and for 265, 275, 285, 295, 305, 315, 325. He lived for 70 years. 70 years. Okay. The Greek mathematician of Euclid's time threw of geometry as an abstract mode of the world in which they lived. So here, book one of the elements. A few of them are given below. So this is what Euclid gave, 7 postulates. and he had many things like Euclid had axiom. What can I speak again? Axiom postulates. A point is that which has no part. A line is breadthless length. The end of a line, a point. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface and lines. A plane surface is a surface which lies evenly with the straight lines on itself. Things. Now, Euclid's axioms. Here we go. Things which are equal to the same thing are equal to the one another. Okay. For example, things which are equal to the same thing are equal to one another. Now, if equals are added to equals, the wholes are equal. So, for example, I have two. Okay, this is 2 and this is 2. So, if equals are added to the equals, they become a whole equal. If equals are subtracted from equals, the remainders are equal. Things which coincide with another are equal to one another. The whole is greater than the part. Things which are double of the same things are equal to one another. Things which are halves of the same things are equal to one another. Let's go with postulates now. A straight line may be drawn from any point to any other point. Given two distinct points, there is a unique line that passes through them. A terminated line can be produced indefinitely. A circle can be drawn with any center and any radius. All right angles are equal to one another. If a straight line falling on two straight lines, making the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. I'm searching. Wait, not here. Wait, yeah. All the summaries here written. Let me read this. This is more example. This is the whole summary of the chapter. We can just read this. In this chapter, you have studied the following points. Through Euclid definition, defined a point, a line, and a plane. The definitions are not accepted by mathematicians. Therefore, these terms are now taken as undefined. Nobody can define them properly. Okay. Axioms are postulates are the assumptions which are obvious universal truths. They are now proved. Theorems are statements which are proved. So, theorems which are already proved using definitions, axioms, previously proved statements, and deductive reasoning. Now, axioms of Euclid. Some axioms of Euclid. Here we have 7 axioms in the line 1, 2, 3, 4, 5, 6, 7. So let's read the first one. First one. Things which are equal to the same thing are equal to one another. Second, if equals are added to equals, the wholes are equals. Third, if equals are subtracted from equals, the remainders are equal. Fourth, things which coincide with one another are equal to one another. Fifth, the whole is greater than the part. Where we said six, things which are double of the same things are equal to one another. 7, things which are halves of the same things are equal to one another. Postulates. A straight line may be drawn from any point to any other point. Postulate second. A terminated line can be produced indefinitely. Postulate third. A circle can be drawn with any center and any radius. And fourth, all right angles are equal to one another. Now let me show you some meanings of some word. I've written them in my book. So let me just show you that also. Then we are going to end the video. Not going to make it boring. And I know I'm a very boring teacher. No need to comment down. Wait, I'm just going to turn off the comments. Haha. Wait a second, let me just turn it back. Line segment. What is a line segment? Everybody is learning this from, I think, 6th standard. Yeah, line segment. The straight path between 2 points is called line segment. For example, there is a path. So here we have 2 lines they are like a triangular, and between them we make a line like this. They are like this, and I'm going to draw it afterwards and show you in the next video. Ray. A line with a start point but no end point. For example, we start a line like this and we never have the end point. Then it will continue. It's called a ray. Intersecting lines. 2 lines with a common point are called intersecting lines. Parallel lines. So parallel lines, I think everybody knows. It's very easy. For example, wait, let me just show you. Yeah, I have a scale. Okay. So these 2 lines you can see. Don't just ignore this part and leave them. Just think there is no part like this or this. just think there is the lines are going like this straight. They're never intersecting or doing anything. So two lines in a plane without a common point are called parallel lines. Now half lines. Now half line I think you have not studied. Let me just teach you this. Half lines. A straight line extending from a point indefinitely in one direction only is called a half line. So a straight line extending from, like for example, I have a line at this point and it's still going on indefinitely in one direction. Or for example, or it can be anything. For example, this side I have, then it will go this side. This side I have, it will gonna go this side, and it will keep on going. It will never stop till infinity. It's gonna still go. Concurrent lines. Three or more lines intersecting a same point are called concurrent lines. For example, like I made a straight line, straight angle like that, 180-degree straight line. Then I take more than three, like this, one like this. For example, this is my straight line. Then for example, this is my straight line. So I'm just gonna take a pen. Wait, where is this? Yeah, wait, I'm gonna show you. This is my point line. Ignore this. Let's go. One is going like this, another is going like this, another one is going like this, intersecting a line. Okay, more than three or more lines. And for parallel lines also, let me show you. Wait, let me show you for this topic also. For parallel lines, it was how, like this, one line, another line. For example, railway tracks, you must have seen intersecting lines. Two lines with a common points are called intersecting, right? So example, I have what can we say, like this. Okay, a point. Now two lines with a common point. For example, one line is going like this, another one is going like this. Same intersecting line. Line segment. Wait, ray. Let me show you ray. One is going like this and it keep on going. It will never stop. From one point, it will keep on going. It doesn't have any other point. And line segment, a straight one between two lines. For example, I have this, and now between them I'm gonna draw a line. Just ignore this is rough work. Now collinear points. Three or more points in a plane are said to be collinear if they all lie in the same plane. Okay, three or more points, as we see here, in a same, like this, three or more. You can take concurrent lines as the example. Plane. Now what is a plane? Everybody knows that. A smooth flat surface which extends endlessly in all the directions is called a plane. So normal figure. For example, it's going like this, or it's going like this, or it may be going like this, anything. Normal figure. Okay, and now I have one question for you guys. I'm gonna write it down and I will pause the video for some time. I will show you. You will have to solve that. Okay, because it has reference to the next chapter, lines and angles also, and from this chapter also. And I think that question, I think you shall solve. And at the end of the video, I will also show the solution of the question. So we are gonna make this video like for only 20 or 21 minutes something. So let me just pause the video and make that question for you. And it's very easy and it will give you reference to the next chapter. Okay, lines and angles. It's a very easy question. Okay, let me just stop. Okay, so here's the question. I think you can see. I hope you can see. And see, the question says this is a lines and angle. You must solve it. Okay, it's very easy question. Like if you shall solve this, I will explain the video on this. I will explain a bit more nicely on this chapter. I will make parts on this chapter. But now that Euclid geometry I've taught till there, I don't know if you have understood or not, but I hope you understood. Now let's see the question. In the adjoining figure x, y and z, x is 5. Okay, wait, let me just correct this. I think x is 5, y is 4 and z is 6. If x or y is a straight line, then find the values of x, y and z. Okay, so first of all, if it is like this, so here it's written x or y is a straight line. So you shall, maybe without looking over here, you shall solve on your own, or maybe I think I shall wait. I'm waiting for you. If you solve it fast, then I will check. I can't check like that, but maybe just solve it. Okay, 10, 9. Okay, Wait, let me just solve the question for you. There's nothing much in this. Okay, so here we take, first of all, given. You have to write like this. In this way you shall write given. In given it is written x o y is a straight line and x is equals to 5, y is equals to 4, and z is equals to 6. Okay, so we can do it like this, that okay, so given you have written, then now we have to write here to prove. So we can write it as, we have to prove the values of x, y and z. Ignore that sound, it's nothing. Okay, now we are going to start with the sum. Now first of all, now take a blue pen. I'm going to take a, you can note it down with me, it's lines and angles question. Now let's start. So here we can see, first of all you have to write x o y is a straight line. You have to always write this if it's given, straight line. Now we can write it at, now let x is equals to, let it be like, for example, any alphabet with it. We can just write, I think p, like, no p, let's just write t. Okay, let x be t, y be 40, and z is equals to 60. It's given, right? So now we have to write it like, we have to write now down x plus y plus z is equals to 180 degree. Now 180 degree is given. Now we are going to do it as 5t plus 40 plus 60 is equals to 180 degree. Now you know 5t plus 40, 90 plus 6, 15t is equals to 180 degree. I hope you can see 180 degree upon 15. So what comes at 15? So we can see 15 11s are 165, and then it comes t is equals to 12. Now you have to find the values. Let me just make a column over here. Now t is 12, right? So as we had written, 5t x is equals to 5t is equals to 5 into 12, and 12 as a 60. Now next is y is equals to 40, so it will become 4 into 12. So everybody knows what is 4 into 12. 4 into 12 is 12, 18, 48. So 4 into 12 is equals to 48. Now, and z. Now let's find of z. Z is 60. It will become 6 into 12, which will become 72 degree. So here we found the answer in a very systematic way. If you follow this, like, you have to write first given and then to prove, then every teacher is gonna give you a nice sign on your hand or something. Maybe not, like, you're not a kid now, so they are gonna give you a nice, like, a nice way you have done it. And I think the video is getting too long now and you guys are getting bored, so I think I shall end this video over here, and let's just, now you can just enjoy the, like, outro song. And please, like, my reading is not so, like, it was not so good, I know that, but still I'm gonna upload as I have no other option. And please, I will correct it next time, and I will, now in the next video, I think I will solve some sums from lines and angles. Okay, we'll just leave Euclid geometry. I will just solve some sums from lines and angles, R.S. Agarwal book. So everyone shall have a book. Wait, I'm showing you what is the book. Wait, this. Remember this book. Please remember this book. We will be showing on this book. And I'm ending this video here. Thanks for watching. Bye.